Good morning. Today we're going to talk about the RFD and relative strength analysis that we have in the Exsurgo Performance System under the Data Analysis tab. So navigate over to eps.exsurgo.tech. Go ahead and sign in. Here we are signing in. And once you're in here, we're going to go over to the Data Analysis tab. We're then going to select a team Rebel, and we're going to select our demo player one. We're going to go ahead and load into that, and then we're going to select the report. You'll see that we have RFD Strength Ratio here. Now, what we're going to do is we're going to select an isometric mid-thigh pull assessment. This is our max strength for the isometric mid-thigh pull. Then we're going to select an isometric mid-thigh pull RFD assessment, which is different. It is basically how hard and how fast can you pull. Now, once you've selected both of those, go ahead and hit generate. And here we go. So you can see player one, athlete, 88 kilograms. You can see that the isometric mid-thigh pull here was 153 kilograms. And then we're looking at the isometric mid-thigh pull RFD, the fast pull, which is under 200 milliseconds, and it was 131.7 kilograms in 150 milliseconds. Now, what does all this stuff mean? Well, let's take a look at the relative strength ratio. The relative strength ratio is the amount of strength divided by body weight, and it gives us a 1.731. So when you see numbers that say must have 2.5 times body weight deadlift, the NCAA loves to, or researchers like to put out, or maybe it's not even researchers, maybe it's just people writing articles, love to put out the strength metrics that you should be able to bench press, certain times your body weight, deadlift a certain times your body weight, squat certain times your body weight in order to be elite. They have all these different classifications. One of the things that we're doing with this is giving these tools to everybody so that it's super simple to use an isometric mid-thigh pull, RFD assessment, literally one device. You can do this on the gStrength. You can do it on force plates, but it's one device that gives you two numbers compared with your body weight to give you your relative strength ratio. So here we are with a 1.731. It's strength divided by body weight. It is a ratio of peak force to body mass, highlighting max strength compared to your body mass. So a higher value indicates a stronger strength to mass ratio. Why is relative strength important? Relative strength is important solely because it is your ability to move weight in relation to your body. Now, let's move down to RFD strength ratio. RFD strength ratio is what you pulled from the isometric mid-thigh pull, rate of force development pull, the fast pull, divided by your strength. So here you'll see a 0.8, it's 86%, right? That should not be 0.86% because it's 86%. This is how fast and how much you pull in a short amount of time, very short, right here, 150 milliseconds, and that's divided by your max strength. So there's some research being done by certain people, and they're saying anything that's 70% or above is great expressions of RFD strength. And so RFD strength is really how fast can you produce force and how much force is that? So if you have someone who is super strong, but their RFD strength is low, you need to look at what kind of athlete are they? If they are a athlete that needs to be really strong, really fast, but their RFD strength ratio is low, then you're probably going to have to make some training adaptations, alterations there. If they're really strong and can't express that force, some kind of training will have to be implemented to get them to express that force, express that strength faster. If they're weak, what do you do? What do you go and work on? Suggestions may be that, hey, let's work on developing that base of strength But then once we've developed that base of strength, we need to step away from that and express that strength quick. So in relation to body weight, we do a relative RFD ratio. And that takes the strength, the RFD max pull at 150 milliseconds, or wherever it is in the 200 millisecond window, whatever that max is, and it compares it to body weight. There's not a lot of research on